Okay, welcome to today's Explainer. We are looking at a really intriguing lesson plan today from the Academy that tackles a giant topic, literally. It's an educational deep dive into the systems and models in science, specifically focusing on exactly how we comprehend scale, proportion, and quantity. So let's dive right into this fascinating exploration of how we measure the absolutely massive and the incredibly tiny aspects of our world.
Now, to set the stage, the source material actually opens with a quote from Isaiah chapter 40, verse 12. It asks, "Who has measured the waters in the hollow of his hand, or with the breadth of his hand marked off the heavens?" The curriculum uses this specific verse to frame its scientific perspective, putting forward the idea that the universe is just unimaginably huge. And this vastness presents a very real problem for human scientists trying to study it from our tiny vantage point here on Earth. But as the lesson plan points out, we've developed specific conceptual tools to help us wrap our heads around it.
Here is a super quick roadmap for today's explainer. We're going to cover measuring the universe, outline 3 essential science tools, apply them to science in real life, test your knowledge, and finally look at education, morality, and peace.
Starting with Section 1, Measuring the Universe, and the specific problem of size and speed. Think about it. We have to start by acknowledging a fundamental, everyday challenge. Some things are literally impossible to study directly with our limited human senses. As outlined by the source, scientists face 4 main hurdles when they try to operate without using models. First, some things are simply too small to see. Think of atoms, bacteria, or complex cellular structures. Second, other things are just too large to measure directly, like the vast distance between galaxies or the sheer volume of an ocean. Third, certain phenomena are way too fast to catch in real time, such as the speed of light or a rapid chemical reaction. And finally, some processes are just incredibly slow, so we can't observe the changes, like the erosion of a mountain range or the shifting of tectonic plates over millions of years. Because of these extreme physical limits, scientists absolutely have to rely on models and measurements to understand how these complex systems actually work.
That brings us to Section 2, 3 essential science tools for unlocking the universe.
So, what's really interesting here is that the curriculum gives you the exact 3 keys you need to solve that problem of size we just talked about. The very first tool is scale. Our source defines scale as the size relationship between a model and the real thing. For example, think of a map that uses 1 single centimeter to represent 1 entire kilometer. Scale is incredibly powerful because it allows us to shrink a massive, unmanageable area down to a size we can actually hold in our hands and easily compare. Or, conversely, it lets us blow up a microscopic organism into a giant diagram we can study on a whiteboard.
Next up is proportion. Now, proportion compares sizes or amounts relative to each other within a given system. For instance, you could look at the ratio of students with glasses in a classroom to those without glasses. While scale deals with the overall physical size of a model compared to reality, proportion helps us understand the internal relationships between the different parts of a whole system. It ensures that as we scale things up or down, the relative sizes of all the parts stay completely realistic and true to life.
And our third tool is quantity. Quantity refers to the specific measurable amounts we are dealing with. We're talking about things like liters of water in a beaker or kilometers traveled by a car. Quantity is simply the hard data that answers exactly how much or how many we are looking at. It basically grounds our scaled and proportional models in exact standardized measurements. Now here's the catch with all of this. Accurate models absolutely must use the correct scale and proportions to reflect reality. Misleading models, however, use the wrong scale or completely skewed proportions. So the crucial takeaway is that using the wrong scale or proportion isn't just a tiny harmless mistake. It actively makes your data misleading and essentially ruins your research or communication. If the scale is off, the model is basically lying to the viewer, which leads to total confusion.
Moving on to Section 3, Science in Real Life, where we bring all this down to earth. Let's look at a few practical examples from the curriculum to see how this builds our understanding of things we experience all the time. First, think about a classroom solar system model. The model is scaled down to fit in the room, but the proportions between the planets are kept realistic, so you can accurately compare Jupiter to Earth. Or think about recipe adjustments. If you are doubling a recipe for a party, proportions ensure that every single ingredient increases at the exact same rate to keep the flavor perfectly balanced. And lastly, measuring rainfall.
When scientists record 25 millimeters of rainfall in a day, that specific quantity tells us exactly how much precipitation fell, allowing us to compare it directly with other days or other locations. It brilliantly illustrates how we use scale for a classroom solar system, proportion to keep our doubled cooking recipes tasting great, and quantity to measure daily rain.
All right, Section 4, Test Your Knowledge. Yep, it's homework time.
The lesson plan actually includes these 5 review questions to really test your grasp on scale, proportion, and quantity. Go ahead and take a quick screenshot or just pause the explainer right here so you can write these down for your homework. Trust me, actively answering them is how you truly retain these concepts.
And finally, Section 5, Education, Morality, and Peace, focusing on the heroesmartacademy philosophy.
Before we wrap up, the source material takes a really interesting turn and zooms in on your own mind and choices. The curriculum leaves us with a pretty stark statement. Education without morality will hurt. According to the lesson plan we're reviewing, just learning the mechanics of science isn't the whole picture. The source asks us to reflect on our application of knowledge. I mean, we have to ask ourselves, what is the point of being highly educated if you just continue to make bad choices that cause hurt to yourself and the people around you? Raw scientific knowledge, they argue, really needs a moral compass.
To provide that compass, the curriculum points to Romans chapter 8, verses 6 through 7, which it states promises peace of mind to everyone who keeps their mind spiritual. And this is exactly why the Heroes Mart Academy intentionally intertwines biblical morality with their science education. The authors argue that engaging with their philosophy brings actual, tangible peace of mind to the student right alongside their academic achievements.
So, as we close out today's explainer, the lesson leaves you with one final, major thought to ponder. As you master science, mathematics, scale, proportion, and quantity, I want to leave you with this ultimate question to think about regarding your own life and future. How will you use your education to make good choices? It's definitely a powerful idea to chew on as you continue learning about the vast universe around you. Thanks for hanging out with me for this explainer, and keep asking those great questions.